Good morning, students. First, I would like to welcome you because you are in the class 11th, just after passing the class 10th. You attended the class 11th, so it is a matter of happy that after your success, you are promoted to class 11. And whatever you learn in class 10th and the course of class 11th is far different from that of the class 10th. So you don't bother for that syllabus, you enjoy chemistry because your life will become happy when you feel happy. So you read chemistry to correlating it with your surroundings and what is the role of chemistry in your life. So in a nutshell, I would like to say that right from the morning of your life and at the bedtime or at the night, whatever you use, that are the gift of the chemistry, and this is the that are the gift of the chemistry, and we say, and these chemicals are invented by certain chemists that helps to lead a very happy and pleasant life. So the chemistry has a tremendous advantages in our life in the different field. We say that in the field of agriculture, in the field of medicine, in the field of warfare, whatever field we recall, that are the gift of the chemistry. So we should be very thankful to our chemist who invented such a chemical and such a material, and in that help that gives provides the basis for our life. So you enjoy the chemistry in your life. So I would start today the topic little bit. You have some knowledge that you learned in class 11. So I would not like to discuss those things that you are not known about it. So you have heard the name of the mole and the mole concept. So our today's objective is to discuss the mole concept. Mole concept. So what is in class 11th generally in class 9th generally students feel problem how the problems of the mole is solved, and that creates the difficulty at that stage. But if you have the perfect knowledge of the mole concept, then you can solve the problem even in the stoichiometry and in the solution that involves the calculations of the moles. So we know about the moles. In chemistry, we know that the number of atoms, ions, molecules, they are very, very large. They are in millions. They are very difficult. So it is very difficult to count the ions, count the atoms, count the molecules, and count the electrons. So it was the problem at that time before the chemist how it should be dealt or handled with the easiest way. So simply we take an example. When we go to the market and we say, instead of saying give me 12 eggs, what we would like to say, give me 1 dozen. So 12 peas is equal to 1 dozen. So it is made very easy. Suppose we have to buy 24 copies. Simply we say, give me 2 dozen of copies, 3 dozen of pen, instead of saying 36 pens, right? That's why in the chemistry, this mole concept was introduced, and this is equal to the Avogadro number. So what is mole? So mole is a group of particles which is equal to Avogadro number. That is one group of particles. So simply we write 1 mole is equal to, that is Avogadro number, that is equal to 6.022 into 10 to the power 23. This is called the Avogadro number. So this Avogadro number is defined as the number of atoms present in 1 gram of the element. That is, Avogadro number may also be defined as the number of atoms present in 1 gram of the element or the number of molecules present in 1 gram of molecule of the substances. So, knowing the concept of, so simply we said in the simple way, we say mole kya hai? It is a group of particles. It is a group of particles. Group of particles. Group of particles, and that particles may be atoms, may be molecules, may be ions, may be electrons. That particles may be atoms, that may be molecules, that may be ions, positive or negative, that may be electrons. So these are called this is a group of particles, that is, it is a group of particles, and particles is equal to atoms, ions. Particle contains atoms, molecules, ions and electrons, and which is equal to Avogadro's number. This is 6.022 into 10 to the power 23. Now, as per the so many concept of mole has been, so many definition has been given, but the accepted mole, the amount of the, in the bookish way, we defined as mole is the amount of the substance which contains the same number of elementary particles as are present in 12 gram of carbon, that is C12. That is, it is the mole is the amount of the substances which contains the same number of elementary particles as are present in, that is 12 gram of carbon, that is C12. So we know about, that is mole and atom. 1 mole of an atom. So we have 1 mole of an atom. Suppose, so there is a simple addition. 1 mole of an atom is equal to gram atomic mass or gram atom. And this is 6.022 into 10 to the power 23 atoms. This one. This one. So simply, the students, you feel how the problem is solved on the basis of this one. So we can write it as V, that is 1 mole of an atom is equal to gram atomic mass, and is equal to 6.022 into 10 to the power 23 atoms. So this is the simple way. This is the simple way that we can correlate this one. This is the simple way. This is 1 mole of an atom is equal to gram atomic mass. Gram atomic mass is the atomic mass expressed in gram, then it is called the gram atomic mass. Similarly, this is equal to, so we can write it 1 mole of an atom is equal to 6.0223 into 10 to the power 23 atoms. And we can write that 1 mole of an atom is equal to gram atomic mass. So, how we will calculate the problem based on it by that concept. So there is so we see so what is the formula of this compound? We write, that is calculate the mass calculate the mass of an atom of silver. right? Ag, that is called silver, and it is atomic mass is 108 U. This is unified mass, right? The atomic mass unit. So how we will define it? This is the 1 mole of silver atom is equal to gram atomic mass, gram atomic mass, atomic mass. This one, gram atomic mass. Now 1 mole, this is 1 mole is equal to 108 gram. Or this 1 mole of atom is equal to 6.022 into 10 to the power 23 atoms of silver. This is 10 to the power 23 atoms. So what we have to calculate? We have to calculate it like that. So this is that is the mass of an atom. So this is 6.022 into 10 to the power 3 atoms of silver has mass, how much gram? We write here 108. This is gram. This is gram. So what we write here? See what we write here. So 1 atom, mass of 1 atom. Therefore 1 atom of silver Ag has mass, that is 108 divided by 6.022 into 10 to the power 23, and you write here the gram. Whatever be the calculation, you solve it. So what is the formula? For that we calculate it. So formula is given, right? Suppose the mass of an atom or of an element of an atom is equal to gram atomic mass, and divided by Avogadro number. So this is Avogadro number, Na, or like this. So the formula is given, and you generally think that how this formula has come. That's why I have taken an example to explain this one. Another, now it is written, that is calculate. Another is calculate the number of moles in 20 gram of calcium. Suppose this is the atomic mass of calcium, that is 40 U, right? That is in gram, that is 40 gram. So how we will calculate it? 40 gram. So we take it in the upper side. So one formula has been deduced. Mass of an element, mass of an atom is equal to gram atomic mass by Avogadro number. How it comes? We see very good. So another concept we take. Suppose calculate the moles in 20 gram of calcium. Right? How we calculate it? Suppose we have the knowledge, we know how. This is 1 mole of an atom is equal to gram atomic mass, now is equal to 6.022 into 10 to the power 23 atoms. This is, so we have to calculate the moles, and we have calculate this one in 20 gram of calcium. So what is we calculate it? So what is the gram atomic mass? This is called 1 mole of calcium atom is equal to, that is how much? 40 gram. So 40 gram is equal to 1 mole. So we write here 40 gram is equal to 1 mole of calcium. Simply we see. Then what we have, this is 1 gram 1 by 40 mole. Therefore this is 20 gram. 20 gram is equal to 20 by 40 mole. Right? 20 by 40 mole. So we see the another formula we have, calculate the number of moles. That is number of moles of an atom. Moles of an atom is equal to what? Is equal to, that is given mass by atomic mass. Atomic mass. So this is the formula we deduce. This is the second formula. Mass of an atom is calculated, gram atomic mass, by this one. If mole have to calculate given mass by atomic mass, this is 20 by 40, we are able to calculate it. Now in the same problem, so this is the calculate the moles. So this will be the moles. 20 by, this is equal to 1 by that is 2 2s are 4, 1 by 2. This mole will come in 20 gram of calcium. So another formula is deduced. Now from this we are able to calculate. So another problem in that. So we raise it. Another. Suppose you have been asked in that problem, calculate the number of atoms. Number of atoms of calcium. So there are two ways to solve that problem. From this concept, that is, suppose first way. How? Gram atomic mass, we have to calculate the number of atoms, that is 40 gram. Gram atomic mass of calcium, 40 gram of calcium contains 6.022 into 10 to the power 23 atoms. इसलिए 1 gram will contain, that is 6.022 into 10 to the power 23 by 40 itna atoms. Another way, that is 20 gram. 20 gram will contain, that is 20 multiplied 6.022 into 10 to the power 23 atoms by 40. This itna atoms will contain. This one, this is the one way. And another way, how we calculate it. Another way, we calculate it. Another way. Another way to calculate, second way. How you will calculate? First step, calculate number of moles. Calculate moles. So what is the moles? Moles is equal to given mass. We have to use the formula by atomic mass. So this is the easiest way. This is given mass is for 20 and this is 40. Itna, that moles will be obtained from this. Now we have to calculate the atoms. We know 1 mole of calcium atom, because the atom is calcium. Calcium atom contains 6.022 into 10 to the power 23 atoms. Therefore, how much mole? This is 1.2. This is 1.2 moles. Therefore, 1.2, that is 0.5. that is 0.5. We write here 0.5 mole. So this is 0.5 mole will contain, this is equal to, that is 0.5 multiplied 6.022 into 10 to the power 23 atoms. So the only way is 1 mole of an atom is equal to gram atomic mass, and 1 mole of atom is equal to this one. You see, if the mass is given, atom can be calculated by this one. If the atom is given, then mass can be calculated by this one. So by that formula, there are moles can be calculated, number of atoms can be calculated by this formula. This is all about that is mole, 1 mole of an atom, that is correlated with gram atomic mass and the number of atoms present in A, that is present in 1 mole of such atom, because it is equal to Avogadro number. So Avogadro number is very important for you. So how we'll calculate the numerical based on the mole concept relating to mole and atom. Suppose the problem asked in this way. Suppose the problem. This is only depends upon the problem. So question, which among the following contains maximum number of atoms, that is 1 gram, 1 is 1 gram, 1 gram Au, that is gold, that is 1 gram sodium, third one 1 gram lithium, and fourth is 1 gram Cl2. So this the multiple choice type of question, and no need to solve these questions. So how you will solve this is just simple trick. So there you calculate the that is moles. Moles is equal to, that is mole is equal to 1 gram, that is mole is equal to 1 by atomic number of suppose it is 197, weight by atomic weight, right? Au is given 197 U, and sodium is given, that is 23 U, and lithium is given, that is 7 U, and the chlorine is given, that is 35.5. This is right, 35.5. So there are 2 chlorine atoms there. So this is multiplied with 6.022. So 0.22, 0.6.022 is not 23. This one is atom. So 1 gram will contain this atom. So we can write this is 1 gram. 1 gram. First will contain this one. The second will contain like this for 1 by, that is 23 gune 6.022 into 10 to the power 23 atoms. Because we calculate from that mole, and 1 mole contains this atom, that's why simply we multiply this atom, right? First we calculate the mole, and mole it is converted into that one, that is 1 gram. 1 gram will contain how much atom? This is 1 gram, that is mole, and mole is equal to, that is this is 1 gram of Ag will contain this atoms, 1 gram of sodium will contain these atoms, and similarly 1 gram of lithium will contain 6.022 into 10 to the power 23 atoms. Similarly, this is 4, this will contain 1 into 35.5, this one, and this is 6.022 into 10 to the power 23 atoms, like this. So there are 2 atoms, so multiplied here is 2. This is 2. So you will see in the denominator, the figure is smallest, the quotient will be larger. So that question can only be answered by seeing that is the denominator, which is in this one, because all will have the same 1 1 1 1. That will depends upon it. So when you will divide it, it comes to a very decimal point something something something. So that's why though lithium will contain the largest number of atoms in this in 1 gram of all the element, that is 1 gram lithium. 1 gram is all. So lithium will contain the largest number of atoms. So this is the atom and the mole. Now simply we consider the 1 mole and molecule. 1 mole and molecule. So we take it as mole and the molecule. So we take the mole and the molecule. So we take as mole is equal to given mass by atomic mass. If atom, atomic mass for atom, we write here for atom. Now mass of an atom is equal to, that is atomic mass by Avogadro number. Right, this one. Now 1 mole of a molecule. So how it will be related? So we write here 1 mole is equal to gram molecular mass, gram molecular mass, another, that is 6.022 10 to the power 23 molecules. And again we write here, that is if volume related with mole and volume, that is 22.4 liters at STP, standard temperature and pressure, or normal temperature and pressure. So we can write is 1 mole of a molecule, whatever be the molecule is equal to gram molecular mass, gram molecular mass. So we can write here the 6.022 into 10 to the power 23 molecules, right? Similarly, that is if it is related with volume, then it is written 1 mole of a molecule is equal to 22.4 liters at STP. And if we take it in milliliter, then it is equal to, that is 22,400 cc, and 22,400 cc. 1 liter is equal to 1000 cc. So this is a relation, they all are equal. Now similarly here, mole is equal to mole of a molecule. In molecule, no need to again deduce it, molecule is equal to, how we calculate the in molecule, how we calculate in molecule, yeah, for molecule, right here, for molecule, mole is equal to what? Similarly, the given mass by molecular mass. Similarly, one definition, this one. Another is mole mass of a molecule. What is mass of a molecule? Is equal to gram molecular mass, yeah, molecular mass by Avogadro number. So this is the formula can be derived. Is it clear? This is the formula can be derived from 1 mole of a molecule is related with gram molecular mass. That is 1 mole of a molecule will contain is equal to the gram molecular mass, whatever be the molecule, its molecular mass. How we calculate the molecular mass? It was in class 9th. So by adding the atomic mass of respective atoms, we are able to calculate the molecular mass. Let us be seeing a problem. So this is the earlier concept that you learned in class 9th. So another is how one mole is related with the molecule. Suppose asked to calculate the molecule, we are able to calculate the molecules. Now, if the volume in liter is asked to calculate at STP, then it is related to 1 mole of a molecule will occupy, that is 22.4 liters at STP. So we see the problem based on this structure, based on this mole and molecule concept. So you see, so this is the formula. Now you take. Suppose we take the one problem and we can explain all the things by taking the one problem. Suppose we have to check. Calculate the number of, calculate the moles in 5.3 gram of sodium carbonate. Calculate the moles in 5.3 gram of sodium carbonate. Calculate the number of molecules third one, calculate the number of each atoms. So how we'll solve the problem? Let me see. So we have the concept, that is mole is related with the gram molecular mass, mole is related with the number of molecules present, and mole is also related with the volume at STP. So we take one by one. So there is a formula. So simply we calculate, not going to the theoretical method, we calculate moles. That is given mass by this one, molecular mass. And this molecular mass, so the given mass is here, what is 5.3 gram. So what is the molecular mass? The problem is calculation of molecular mass. So I think you have the knowledge to calculate the molecular mass. Let you see. That is calculation of molecular mass of Na2CO3. So what is the atomic mass of sodium? Already it is given in the question paper, although you should remember the atomic mass. 23 multiplied 2 plus what is the atomic mass? Number of atoms is 2, that's why we multiply. And this is the algebraic sum, we add it. Then 12, number of atoms is this. And atomic mass of oxygen, that is 16, number of atoms is this. So when you sum up, it comes to be, this is 106. If it is expressed in gram, then it is called gram molecular mass, GMM. So here we put here 106. So when we solve it, that is, it comes to be 0.05 on solving. Suppose you solve it. Now, so first problem is to calculate the moles. We are able to calculate the moles. The another problem, calculate the number of molecules. How will calculate the number of molecules? So we have the concept. The another problem, calculation of molecules, of number of molecules. How we will calculate it, you see. That is, we know our concept. We go step by step. We know 1 mole of sodium bicarbonate, any molecule, here it is given Na2CO3 contains 6.022 into 10 to the power 23 molecules, right? So how much moles calculated here? That is 0.05. If the calculation is right, then it will be this mole. So this is equal to, so this is 1 mole, therefore 0.05 mole will contain, mole of sodium carbonate contain, what contain? That is 0.05 multiply 6.02 into 10 to the power 23 molecules. Molecules. So the second part is also done. First part was also done and second part is also done. No need to calculate by unitary method. 53 gram, 106 gram will contains of sodium carbonate will contain this is how much? 106 gram will contain this atom, is 1 gram, therefore 5.3 gram. Similarly, the same concept to calculate the mole, molecular mass calculating, we are able to calculate the mole, and our concept, 1 mole of sodium carbonate will contain this molecules. If it is a molecule, then this mole will contain how many molecules can easily be calculated, right? Now the third problem, there is a calculate the number of each atoms. So how we will calculate it? See here, calculation of number of atoms. Third problem is calculation of number of each atom. Calculation of number of each atoms. How we will calculate it? You see, how we will calculate the number of each atoms. So we write 1 mole of sodium carbonate contains 2 atoms of sodium, contains 1 atom of carbon and 3 atoms of oxygen, right? How many mole comes in this gram? That is this one. So we can write as therefore in 5.3 gram of sodium carbonate, it contains how many mole? This mole, 0.05, 6.022, 10 to the power 23 molecules, that is we write here one molecule of sodium carbonate contains this one. So it will contain this molecule. So it will contains, this is twice into 0.05 multiplied 6.022 into 10 to the power 23 atoms of sodium. Likewise, that is 1 into 0.05 multiplied 6.022 into 10 to the power 23 atoms of carbon. Likewise, that is 2 and here 2CO3, 3 atoms are there. 3 into 0.05 multiply 6.022 into 10 to the power 23 atoms of oxygen. So let us see how we will proceed. In order to solve the concept of the problem based on mole concept, our aim, if atom, calculate the mole for the atom, and whatever be the requirement, we proceed as on. In the case of molecule, we calculate the molecular mass, also calculate the what knowledges we have, calculation of molecular mass. If we are not able to calculate the molecular mass, we are not able to find out the number of moles. If we are not able to find out the moles, we are not able to calculate the number of molecules, because our concept, 1 mole of a molecule, whatever be the molecule, will contain, that is how much molecules, 6.022 into 10 to the power 23 molecules. Similarly, so we consider the molecules. Now one molecule of sodium bicarbonate will how many atoms? 2 atoms of sodium, 1 atom of carbon and 3 atoms of, this is 1 atom of carbon and 3 atoms of oxygen. How many molecules obtained in 5.3 gram of sodium carbonate? So this molecule is obtained from sodium carbonate, right? So this molecule is obtained from sodium carbonate. So we correlate one molecule with come this atoms. So this molecules will contain this. Itna molecules will contain. There is a language will contain. Will contains this atoms of sodium, this atoms of carbon, and this atoms of oxygen. So we are easily calculate the problem based on the mole concept. Now one thing is left, that is with volume. Suppose mole and the volume, how we will calculate the volume of this on this concept. But we have the formula, mole and the volume. 1 mole of a molecule is equal to, whatever I gram molecular mass is equal to 6.022 into 10 to the power 23 molecules, right? That is mole and volume. Our aim is mole and volume. This is already discussed. Now here is 22.4 liter at STP, right? So question is asked, calculate the volume occupied by 14 gram of dinitrogen at STP. Like this, you think over it. So what we will do it? Now this is related with this. Now here is a gram molecular mass. Here the molecule is N2. Means 28 gram of nitrogen will have volume this one, because this equal and this equal. So this and this, because we have to calculate this one, because the gram is given. Is it clear? So what we write here, that is gram molecular mass. Gram molecular mass of nitrogen, that is 28 gram. Is it clear? So we correlate this 28 gram, that is 1 mole of N2 will contain how much gram? 28 gram. 28 gram of nitrogen at STP contains volume, that is 22.4 liter. Therefore 1 gram, चूंकि gram to volume, that is 22.4 divided by 28. How much gram is given here? That is 14 gram. That you write here 14 gram. So this is weight, bimolecular weight is this one 28 into 22.4 liter. This is the volume occupied by the 14 gram of nitrogen. Suppose molecules is given, right? Suppose molecules is given and you have been asked to calculate the volume, then we can also calculate at STP, this one. So this is the problem. Now we take another, suppose question, calculate the volume occupied by 1 into 10 to the power 22 molecules of dioxygen O2. Is it clear? Then molecules is given, we have been asked to calculate the volume. So what is the relation? That is 6 point, we know. From this relation, we correlate this and this one, this. Because this data is given, molecules is given. And in the question, it is asked, calculate the volume. We are able to calculate the volume. So, we know 6.022 into 10 to the power 23 molecules of O2 contains what? That is, occupy, the word is 22.4 liters. Therefore, one molecule, that is 22.4 by 6.022 into 10 to the power 23 liter. So, how much molecule is given here? How much molecule is given? So, how much molecule is given? That is 1 into, therefore 1 into 10 to the power 22 molecules of dioxygen will contain 1 into 22 multiply 22.4 divided by 6.022 into 10 to the power 23 liter or milliliter, whatever is the unit, you may convert the unit in that way. So this is the that is about the concept of, we know the mole and the atom, mole and the molecule, and how mole and the molecule, 1 mole of a molecule is related with the number of molecule, with gram molecular mass and its volume, and what are the problems based on it. This is the basic concept, how mole problem can be solved. By one line gives all the information. You have the concept of this equal, this equal, this equal, then we are able to solve the problem very easily. Now, the another topic is problems involving moles, problem involving mole concept in solution. So another, this is the topic, problem involving mole concept in solution. So another concept, problem involving mole concept in solution. So this is our topic. That by the mole, that is regarded with that mole, this is the problem involving in, that is mole concept in solution. So we know the term solution is very that is a useful term, a very well known term for us. Solution, it is a homogeneous or heterogeneous mixture of 2 or more components. Is it clear? You know it very well. And in the solution, how we will consume the solution? There one is the solute and another one is solvent, and when they will combine together, then it form that is the solution. So when we have the talk about the solution, so there are some terms to discuss here, that is mass percent of a compound, mass percent. So we write here the mass percent. Suppose we have 2 components A and another component is B. Suppose let mass is WA gram and the mass is WB gram, and the total mass, this is solvent, total mass, that is equal to WA plus WB. This one is in gram, so we take it as gram, and this is gram unit. So mass percent. So we can define mass percent of a component, that is the mass of a component present per 100 part by mass of solution. Mass percent of A, we write here, that is mass of A divided by total mass of A, WA plus WB multiplied 100. This is the formula of the mass concept. This is mass percent, mass of a component present per 100 part by mass of solution. What does it mean? Means WA plus WB gram contains, if it is a, suppose A is the solute, yeah, that is the solvent, whatsoever. If A is the solvent, then the mass of solvent, total mass of solution, solvent plus solute, and this is 100. So this is this one. Means WA plus WB contains WA gram, therefore 1 gram, therefore this gram will this one. So 20% by mass, what does it mean? 20% by mass. Is it clear? Means 20 gram of the solute present in 100 gram of solution. By mass percent, 20 gram of solute present in 100 gram of solution. 100 gram of solution. So when the problem is asked, then it is written 20% by mass. So how you will calculate the mass of the, that is whatever is the solute and what is the solution. This, what is the mass of, we know solute plus solvent is equal to solution. This one. So if the mass of solution 100 and let it be, that is 20 gram of solute, 20. So the mass of solvent can easily be calculated. This is, that is mass of solvent, it comes to be 100 minus 20, that is 80 gram. So when the problem is asked, that is by mass percent, the 20%, 25%, 40%, whatsoever be that, then we calculate it as the mass percent in this way, right? Suppose 2 gram of anything is dissolved in suppose 18 gram of water. Calculate the mass percent of that substance, right? So we write the mass of that component, total mass 2 gram plus dissolved in 18 gram, we write here and multiplied by here, so we get the mass percent. So another term is mass percent. So we take there is another formula. So we take it at here mass percent. Mass percent of B or A, whatever. A, so WA by WA plus WB multiplied 100. उसी तरह मास परसेंट ऑफ बी निकालना रहे तो जो ऊपर निकालेंगे, जो यहाँ निकालना रहेगा, that will be in the upper side, and the total mass WA plus WB into 100. So we are able to calculate the mass percent of a component. If you assume B as a solute, where B, if B is solute, then A क्या होगा? That will be the solvent. This is. Now similarly, that is volume percent if we take it. That is volume percent. That is volume percent if we take it. Volume percent. Suppose volume percent of A. Suppose VA by VA plus VB, and this is 100 in liter, milliliter. This is in gram, and the volume percent of B, that is WB, that is VB, VA plus VB, and this is in 100, that is milliliter. So we take as a, let again we consider let components are A and B. Let volume B, A and V be, right, in milliliter or liter, whatever. This is in milliliter, this is in milliliter, whatever is the name. Total volume, that is VA plus VB. This is milliliter. So volume percent of A, so it is defined as volume of a component present per 100 part by volume of solution. So this is the another formula. This is for the volume percent. Now we come on the term that is the molarity. molarity. So we take as the molarity, molarity, molarity. So this molarity is denoted by this one, molarity. So this is the new term for you. This is the molarity. This is the number of moles of the solute, number of moles of solute present per liter of solution. Mathematically, M is written as number of moles of solute by volume of solution in liter. Suppose NB considered as, let NB, that is moles of solute. So we know that here the concept of mole. How we calculate the mole? That is given mass by molecular mass. So this mole is equal to weight by molecular weight. So what is the concept? That is the mathematical expression for molarity, WB. Now V in liter. Now this liter is converted into, this is a unit is mole per liter. Mole per liter or capital M. We write here. Mole per liter or capital M. Now if this is in milliliter, then WB into 1000 by MB, that is in volume, this is milliliter. So this is the mathematical expression for the molarity. And what is the molarity? If it is asked, number of moles of the solute present per liter of solution. This is the definition. So it can be represented as number of moles by volume of solution in liter. Now we have the concept how it is involved in that solution. Number of moles can be calculated by our concept weight by molecular weight. Now this weight by molecular weight, instead of NV, we put here that is weight by molecular weight, that is V in milliliter, then if it is in liter. Now the volume is given in milliliter, because there is simple thing. 1 liter is equal to 1000 milliliter. So if it is 1 milliliter, that is equal to 1 by 1000. That's why this 1000 liter. So already it is in liter. So it comes here, the 1000, 1 by 1000 goes here. So there is no chance of any confusion. And the unit is written mole per liter or the molarity. Whatever is the unit, you write it. Now one thing is asked here. So what is the effect of temperature on molarity? So you will see here, effect of temperature on molarity. So we have the simple expression, M is equal to, that is number of moles per liter. Is it clear? Or this one? Now when we increase the temperature, T increases. When T increases, is it clear? Then when T increases, what will happen? The intermolecular force in the liquid, that is will decreases. So there will volume will increases. T increases, volume increases. This is, now when volume increases, volume is the denominator. So then what will happen? As this increases, this decreases. So on increasing temperature, molarity decreases. So there is a symbolic for molarity decreases. And this is T increases. If T increases, then molarity decreases. So this is the simple relation. Now, so we take, there are some another, suppose the problem based on this one. How we will solve the problem? So we see the calculate the molarity of a solution in which solution obtained by dissolving 4 gram of NaOH in excess of water and in excess of water having in excess of water volume, excess of water in excess of water, the volume of the solution 250 milliliter. 250 milliliter. So first from this we are able to write the data. Molarity we have to calculate states by formula method. Molarity we have to calculate. Obtained dissolving 4 gram of NaOH, weight 4 gram. Now this is NaOH, so its molecular weight is equal to 23 plus 16 plus 1, that is 40 gram. So from that we are able to calculate when it is dissolved in water, the volume of the solution, when the solution is formed, when NaOH is put into the water, right, the solution will form, and this solution will have volume, that is volume 250 milliliter. So we put all these values here, that is weight is given 4 gram. Now molecular weight is 40 gram, 4 gram, this is 40 gram, and this is volume is 250, and this one is 1000. So you solve it and write it in a M. That problem based on this can easily be calculated. Is it clear? Now there is a molarity equation. So we learn here the molarity and what is the effect of temperature on molarity. Now how mole is involved in the calculation of molarity, because the thing is mole. That's why the heading is problem involving mole concept in solution. How mole is involved in the solution. This is the thing. Now molarity equation. We take another is molarity equation. So we have the formula. We have put the formula here. This is molarity is equal to weight by molecular weight into volume of in milliliter multiplied by 1000. This is, and the term used weight is the mass of the that is given mass of solute. This is where WB mass of solute. This is specification you know, and molecular weight MB molecular mass. So this is we have solved this problem in this way. Now that is a molarity equation. So molarity equation. How we calculate the molarity? Use the molarity equation. Suppose a solution. Suppose the strength on molarity. We say strength is expressed in terms of that molarity here. So here, if the strength of one solution is known and molarity of one solution is known, now we have to prepare the another solution whose molarity is known, and in how much volume we have to prepare it is also known. Then what amount of that solution be needed, and that can be done with the help of this equation. So M1 V1 is equal to M2 and V2, where M1 molarity of the first solution, V1 volume of the first solution, and M2 molarity of the second solution, and V2 is the volume of the second solution. So if we write these things here, where M1 molarity of first solution V1, volume of first solution, this is M2, molarity, this is molarity of second solution, and this is the V2, volume of second solution. We can do it. So if the molarity is known and the molarity of the solution which are to be prepared is known. Suppose that is the molarity of such solution is known, and the molarity of this second solution is also known, and how much amount in what will be the volume, up to what liter or what volume we have to prepare, it is also known. So how much solution of molarity is needed to prepare, we can easily calculate it. Right? Now another equation, molarity for a balanced chemical equation. So we can use this. So there is another formula, molarity for balanced chemical equation. So how we will write it? Suppose M1 V1 by N1 is equal to M2 V2 by N2. So what is here? This is M1. This is for a balanced N1 and N2 are the moles of the reactant of a balanced chemical reaction. This M1 and V1 are the volume and the molarity, and N1 and N2 are the number of moles of the reactant 1 and 2 in that chemical equation. If it is involved, then we can use this equation to solve the problem. So this is about the molarity and the problem based on the molarity. Now we take another concept, that is the molarity. So this is very important one. So we consider molarity. So the word is very confusing. Here is small m, and in molarity that is capital M. So what is how we will define the molarity? Number of moles of solute present per kg of solvent. Present per kg of solvent. So this molarity is defined as M is equal to number of moles of solute Wb, and we take the mass of solvent in kilogram. This is the integer, where Nb, let Nb number of moles of solute. What आपने B माना है, so you take it as B. What is that? Now moles again involved here, weight by molecular weight, this one. So the mathematical expression we are able to deduce is Wb by Mb, and this is Wa in kilogram. If we write in gram, then what will be the relation? If we write in gram, then similar way, Wb by Mb, this one, and here Wa in gram multiplied by 1000, and the unit is mole per kg, or simply write small m. We never write the capital M. That will be wrong. Is it clear? So molality is the number of moles of the solute present per kg of solvent. The word is very important. Per kg of solvent, not per liter of solution. If we talk about the solid, that is solution, that is the molarity, we take the volume of the solution. Here we take the mass of the solvent. So this is the difference between these two. Now what is the effect of temperature on this molality? We see, so there is another formula we write here for molality. This is WB, this one is MB, this one is WA in gram, we write here, this is 1000. So another formula is reduced. Another formula, that is molarity equation. So what is the effect of temperature? You see here, effect of temperature. So effect of temperature. So what will be the effect of temperature? There is no effect of temperature. Why it is not effect of temperature? Because it is not related with the volume. So it is a mass and it is also the mass. So mass to mass ratio, that's why there is no effect of temperature. Effect of temperature, we write here, no effect. Now question, why it will have no effect? Because it is mass to mass ratio. Mass to mass ratio. That's why the temperature has no effect on molality. This is on molality, right? So we take a problem to discuss these things. Suppose the density of 3m solution of NaCl. Suppose we take a problem on this. Problem. So, this is the ink. The density of 3m NaCl solution is 1.25 gram per milliliter. The density of, that is the density of 3m solution of NaCl is 1.25 gram per milliliter. Calculate molality. Calculate molality. So we think here how we will solve this problem. Now the formula is written on your board. That is weight and molecular weight, and this is the mass of the solvent. First we know that here the density of solution is given, this 3m, that is density given data, given values. You see, given values. What are the values? Density of solution. If you are not able to find out, then you will be in problem. So you read the question, what is given? First you have the ability to write the data. That is, density of solution is 1.25 gram per milliliter. And to find out the molality, we need the mass of the solvent. We need mass of solvent. Mass of solvent. Mass of solvent. So we need mass of solvent. So what does mean? 3m NaCl means 3 moles of NaCl present in 1 liter, that is 1000 milliliter. This is 1000 milliliter. Is it clear? 1000 milliliter. So this one. So density, we know density is given. Density of solution is equal to mass of solution and divided by volume of solution. Volume of solution. This is volume of solution. So we have the volume of solution is given 1000 because 3 moles. That is 3 moles plus 3 multiplied by 58.5 gram. This all mean how much? That is this liter. That is 1000 milliliter. So mass of solution we are able to calculate. Mass of solution. So how we will calculate? This is this density into volume of solution. Volume of solution. We can calculate. So when we calculate, we write here 1.25 gune 1000. This is milliliter and milliliter will cancel out. So this is equal to 12. This is gram. So what will be? This is the mass of the solution. But to calculate the molarity, we never use the mass of the solution. We need the mass of the solvent. Now the problem arises, how we calculate the mass of the solvent. So we erase it. So see. Now. So this is this one. Mass of solution. The mass of solute. Mass of solute. 3 moles. 3 into 58.5. What is? That is NaCl. Its formula mass 23 plus 35.5. That is equal to, that is 58.5. This is the from where we calculated this one. That is 3 moles. Mass of 3 moles of NaCl. That is called mass of, we can write mass of 3 moles of solute, that is NaCl, that is this itna gram. Now we multiply it. Now the mass of solute is known and the mass of solution is known. So the mass of solvent can easily be calculated. So mass of solvent is equal to mass of solution, mass of solution minus mass of solute. We can calculate it now. So when we calculate it, mass of solution is here, that is 1250 gram minus, okay, and minus what is this one? What will be the solution? That is 58.5 multiplied 3, and this one is gram. You solve it, and this is will be the mass of the solvent. Now, how we will calculate the molality? Now we have the formula molality, that is moles, number of moles of solute per kg of solvent, mass of solvent. This is in gram. Now if it is in kilo, that is in kilogram, that's this one, mass of solvent. If it is in, we take in gram, then what will we do? That is number of moles of solute, number of moles of solute, that is, it is given 3 moles. Then it's a mass of solvent in kilogram, that is a mass of solvent in gram multiplied by, this is 1000. So we have how we solve the problem. You said that is first we calculate from the density, we calculate the mass of the solution. From the mass of the solution, we calculate the mass of the solvent. Now, how we calculate the mass of the solvent? By deducting the mass of solution minus the mass of the solute. This one. So, we are able to calculate the mass of the, this is a solution. This is the formula mass. Formula mass. So, this is a, how, from where it comes, that's why I do the work here. Now moles of the solute, mass of solvent in kg. So this is the mass of solvent. We put this by solving, we put the figure here. And the moles, that is 3 is there, and multiplying by 1000, and this will be the whatever be the answer will come, that will be the molality of that solution. So this is a tricky problem. So you solve this problem in this way by that concept. Now this is a one thing I just want to dictate you one thing, that is mole fraction. This is mole fraction. This is mole fraction. Mole fraction. Mole fraction. So mole fraction is represented by x. Suppose let two components, and that components are A and B. Let number of moles, let Na, this is Nb. Let mole fraction, that is Xa, Xb, right? So Xa, Xb, then mass, that is a mass of components, means Wa, Wb, molecular mass Ma, Mb. So we write here this Xa, that is Na by Na plus Nb. Similarly, Nb, Xb is equal to Nb by Na plus Nb. So now how we are able to define the mole fraction? So now we are in a situation to define the mole fraction, that is, it is the ratio of number of moles of one component to that of total number of moles. This is known as the mole fraction. Suppose there are so many moles, that is the components A, B, C. So this is a mole fraction Xa, Xb, Xb, C. Now its mole is Na, Nb and C. So how we will define it? That is, if it is A, then we write here in the upper side A. If it is B, write in this. The total number of moles we calculate it. So now again we define it. Mole fraction is the number. It is the ratio of number of moles of one component to that of total number of moles. If this one. Now the sum of mole fraction of all the components. So there is Xa plus Xb is equal to, we take it as LCM, then it will cancel out that one. So if the mole fraction of one component is known, then we are able to calculate the mole fraction of other component very easily. So we are able to calculate the mole fraction of the other component easily. Suppose the problem is the problem is asked in that one. That is the problem. Suppose we take a problem very easily. here. That is based on problem. Calculate the mole fraction of ethylene glycol dissolve mole fraction of ethylene glycol and water. The solution contains, so we also introduce the concept here, the contains 28% by mass of ethylene glycol. This is the problem. Now the formula is C2H6O2 and this is CS2OH and this is CS2OH. So it's a molecular mass. If you calculate 24 plus 6 plus 32 तो 12 and this is 62 gram per mole. So this is molecular mass. If formula is given, then you have the knowledge to calculate the molecular mass. Right? So this is the formula and this is the mole fraction. And if you have the knowledge of the mole fraction, I have given the problem based on that mole fraction. You calculate. Here is the concept of the mass percentage also given, and therefore ethylene calculation of molecular mass is also calculated, or you have the knowledge to calculate the molecular mass. I have calculated it. And what is the formula of ethylene glycol? Just I have written for your knowledge. You see, the 20% by mass means 20% by mass means 20 gram of ethylene glycol present in 100 gram of solution. So mass of solution is equal to 100 gram. You mind it, 100 gram. So mass of solute, that is ethylene glycol C2H6O2, that is equal to 20 gram. So from here you note mass of solvent. This is 100 minus 20, that is 80 gram. Now that is solvent is dissolved in water. So water is here the solvent. Here water is a solvent, that is water. So you calculate the number of moles of ethylene glycol, that is NC2H6O2. That is weight by molecular weight, 20 by this one. Calculate moles of water, that is this one. So this is 80 by 80. Here the mole is also involved. That's why the heading, that is the problem based on that is mole concept in solution, moles in solution. So here we calculate this one. Now we have to calculate, this is NC2H6O2. So we write here NC2H6O2, then NC2H6O2 and plus NH2O. Is it clear? So we are able to calculate the mole fraction by this one. So the given mass by molecular mass, given mass by that molecular mass. Here in this problem, the mass percent concept is here, 20% by mass means 20 gram of the solute present in 100 gram of solution. That's why it is needed to the mass concept. Now ethylene glycol, the concept how to calculate the molecular mass? So molecular mass is also need to be calculated. Now we calculate the mole fraction. So we know that if we are calculate the mole fraction of one component, so this number of moles can be calculated, this we calculated, put here. Now there is a formula, XA plus XB is equal to 1. That is mole fraction of H2O is equal to 1 minus X C2H5 C2H6 O2. By putting that, we are able to calculate the mole fraction of the other component, or by simply by that formula you can calculate it. That is X H2O, N H2O, N, that is C2H6O2 plus N H2O. And by that method you can calculate, or by simply this one we calculate. So now let us, I want to conclude today's topics. Starting from the mole concept, we got an idea about the mole concept and the problem based on the mole and atom, mole and the molecule, and mole and the volume that can be calculated. And there are so many problems that how to tackle this problem, how we'll solve these problems, we know it. Then how it is involved in the solution, and how we deal the mass percent, volume percent, and therefore molarity equation. There are so many things, and the best problem we are able to discuss you. That's the, I hope that lecture help you to understand the topic in the to a little more extent. And now again I conclude my lecture, we say, with the concept that you enjoy chemistry, you never make burden chemistry in your life, because in your life you are using the chemistry, that is the material that are the gift of the chemistry. And this is the that's why we are very thankful to the chemistry. How chemistry is involved in the different calculations, this is our interpretation. I hope you will feel easy by that lecture, and you go through the book. That's okay, and have a nice day. Thank you a lot. Thanks a lot.